All right, so here's the deal. 3-5 starts with something called the parallel postulate. You'll never have to name the parallel postulate for me, but it just kind of helps you understand the overarching concept in this section. So here's what I need. I'm going to hold the yardstick, and I need someone to come up here and see if they can make the ruler parallel to the yardstick through my finger. You'll see. Okay, so here's my yardstick, right? Here's the point.
It's like that.
Is that better? Okay, now my question is, can he move that ruler anywhere else and still be parallel?
Like that.
Okay, you could do that, right? But same line. Is there a different line that will go through my finger parallel to this? No, there is not. You're right. So the parallel postulate says through any point not on a line, there's exactly one line parallel to the given line. So in other words, if we... What? Draw it out. Okay, so let's say this is our line, right? And I have a point. The only place that I can put a line right now so that it would be parallel to the line that's given. That doesn't look parallel, does it? Close. Okay. So there will be one parallel line through a point that is parallel to another line. Parallel postulate. I'm not even going to write it out because I'm never going to ask you to use the parallel postulate as something, but that's what it says. There will be one line. This one, the next one we're going to talk about is called the triangle angle sum theorem. And this one you can probably tell me what it says. Think about the name of it. Triangle, angle, sum.
Oh.
Thoughts? Yeah.
All the angles of a triangle have to add up to something.
To what, Matthew? To 180 degrees, right. So the triangle angle sum theorem says the sum of the measures of the three angles of a triangle is 180. Okay, so every single triangle ever in the history of triangles that you will ever see will always add up to 180. There is no other option, okay? So if I take a picture like this, for instance, and this is angle A, God bless you, angle B, and angle C, then we would say the measure of angle A plus the measure of angle B plus the measure of angle C. That's ugly. Hold on. Is 180. Why are we so chatty today? You'll talk through me, but you won't talk to me. That's what's going on? Lame. So triangle, three angles. If you add them together, 180 degrees. Okay. So there is a way to prove this, which I'm going to just show you with a triangle here. If I take this triangle and I tear off the corners, right, like this, and then I take those corners and I put them all together, all the angles together, what happens? They form a straight line, right? This makes a straight line on the bottom. Can you see that, or are my hands in the way? Try this. Right? They form a straight line. And a straight line is always how many degrees? 180. So every single time you will get that straight line and 180 degrees. So what you're gonna have to do a lot of in this section is just finding missing angle measures. So let me draw you a picture here. This is not necessarily drawn to scale, sorry. This is 59, X, Y, Z, 49, 43. All right, so you have a picture. How many triangles are in this picture?
2.
3. Thank you, Gracie. So you have the 2 small triangles that are set next to each other, but then you also have the big triangle that if you took this middle line out, right, there's a triangle with the 3 lines that are left. So just pay attention to that because it's super helpful if you can see different triangles because there's different pieces missing to set up to equal to 180. I would say your best bet for solving this setup right now, if we want to know what x, y, and z are, your quickest option right now is to solve for x. How could we solve for x? Yeah, Daniel.
43 plus 59 and then take 180 and subtract that.
Right, so we know that this is a triangle. Okay, so we can say 59 plus 43 plus x should add up to 180. So then if we just simplify this, we get 102 plus x equals 180. And we're going to take away that 102. So our x is 78 degrees. Okay. My other piece of advice for these types of problems is as you do it, I know it's not super convenient because you don't have the like physical picture in front of you. I would draw the picture if you struggle at all with this stuff because when you draw the picture, then you can actually write in your angle measures, which will help you find missing parts because you'll see it then. God bless you. What is so smelly in here that everyone's so sneezy this morning? Is it my air freshener? Are you? That's a bummer. Okay, so x is 78. How do I find y right now? Do you see it? Yeah, Jerry. Right, so this is forming a straight line right now. This is a linear pair, right? So these 2 angles have to equal 180. So you're going to say 78 plus y should equal 180. And then take that 78 away. And I feel like that's one of those things that gets overlooked a lot is the straight line. If 2 angles share a vertex and make a straight line, they have to add up to 180. So you get 102 degrees. Have you seen that number before?
Yeah.
Where? Right here, right? In that first triangle, these 2 added up to 102. That's going to come into play very shortly. Okay? So y is 102. How do I find z? And you could have found z as your first step, a different way than if you find it the way that most of you are probably seeing it right now. Daniel, how'd you find it?
Well, if you did it the first way, you would add 59, 43, and 49 and subtract that from 180.
Right, so your 2 options, right, is if you take the big triangle, those 2 make up angle B, and then angle Z, those 3 angles have to add up to 180. So you could have done it that way. I would say that's not the easiest way because you're adding an extra number in there. Oops. So instead, I would probably use this triangle, the purple triangle here, right? And that would be 102 and 49 and Z. That would add up to 180. So then just take that 151 away. So 102 and 49 together, 151. Take that away, and Z would be 29 degrees. Okay? So you're going to do a lot of that today. Just finding, God bless you, the missing angle, okay? Making sure every triangle adds up to 180. God bless you. Seriously, 1, 2, 3. There was someone else that was sneezing. Someone's causing allergies this morning. Maybe you really are allergic to school. Okay, questions on that? You need that still? Okay, how about this setup? And this is what I was just talking about where we saw the 102 in two different places. This is why. Okay, if I have a triangle, and this is angle 1, and this is angle 2, and angle 3, there is a relationship. Is that real?
Oh no, sorry.
There is a relationship between 1 and 2 and 3 together, okay? Think about it. Well, let me just tell you what these are called first. That way when I'm referring to them, you know what I'm talking about. This angle here is called an exterior angle. And an exterior angle has to be formed by one side of a triangle and then the extension of another side of the triangle. So if I drew this line in right here, this circle is not an exterior angle, okay? That's not exterior, but this one would be. And those are vertical, so they'd be the same, okay? But what we're looking at here is angle 1 is an exterior angle. So it's formed by a side of the triangle and the extension of another side. Okay, so if we extend one side like they did here from angle 2, extend that out, and then use the side of the triangle, that's what's forming the exterior angle. And then these other two angles, so angle 2 and angle 3, are what we call remote interior angles. What does it mean to be remote? Isolated. If I said I went to a remote desert island, yeah, far away, okay? So remote interiors are the interior angles that are farthest away from the exterior, right? So if my exterior angle is here, this little angle here, not a remote interior because it's right next to it, right? We want the two that are farther away from the exterior angle. So remote interior angles is what we call them. But here's what I want you to think about with this setup. If I were to call, let's just call this angle 4 for now so I can refer to what I'm talking about. If that is angle 4, what is 2 plus 3 plus 4? 180, okay? So angle 2 plus angle 3 plus angle 4 equals 180. What is 1 plus 4? 180. So if you look at this, if we take the 4s away, right, 2 plus 3 and 1 have to have the same value, right? It's like the congruent supplements theorem. If they are supplementary to the same thing, then they are congruent to each other. These two things, 2 plus 3 and 1, have to be equal to each other because they add up to 180 with the same angle, okay? So there's this theorem. It's called the triangle exterior angle theorem. And basically what it says is what I just showed you there. So if that triangle, I'm still going to use that same triangle even though you're not necessarily seeing it there. We'll just make it a little smaller. It says the measure of each exterior angle of a triangle equals the sum of its two remote interior angles. So in this picture, actually here, we're just going to draw it again. It's the same picture. You don't need to draw it again, but I just want you to be able to see it. So if this is 1 and this is 2 and 3, we would say the measure of angle 1 will always equal the measure of angle 2 plus the measure of angle 3. Okay, so an exterior angle equals the sum of the two remote interior angles. Okay, an exterior angle equals the sum of the two remote interiors every time. And you are welcome to use that. It's really just a shortcut for you because you can always do it without that as well. And I'll show you what I mean by that right now. All right, so example 2. You're going to get a triangle where this is angle 1, and this is 80, and this is 18, okay? The question is, what's the measure of angle 1? What do you have to do? If you use the triangle exterior angle theorem, what do you have to do? Yeah. Right, so the exterior angle, the measure of angle 1, will equal the sum of the two remote interiors, right? So that means the measure of angle 1 is 98 degrees. How else could you find 1 without using that theorem? Do you see it? Matthew. Right, so if you forget the theorem, it is not the end of the world. It just means you're going to take one more step than everyone else. Because we can find x, because it's a triangle, right? So 180 minus 80 minus 18 would find us x, and then x and 1 have to add up to 180, so you can just subtract that number from 180. So just keep that in mind. If you forget which angles you should add to set equal to that exterior angle, you can always go this route too. Okay. All right, so what would that look like here? If this is 124, and this is 59, and this is angle 2. Okay, the rule says that the exterior angle equals the sum of the two remote interiors. So how would you set up that equation here? Which one's your exterior? 124. So we would say 124 equals what plus what? Which two angles do you have to add together? 59 and angle 2. So it'd be 59 plus the measure of angle 2 should equal 124, and then you'll just take that 59 away. Okay, so that means the measure of angle 2 equals, this goes away, 124 minus 59 is 65 degrees. Okay, so that's remote interiors with an exterior. Last one. God bless. That is not a good. All right, so say this is 80, this is 30, and this is x. What's your equation? How would you set that one up? What's your exterior angle? 80. Okay, so that's always the standalone. The exterior is always by itself. And then what are you adding together? 30 and x. 30 plus x. So then just do the algebra, take away the 30, and you get 50 for x. So x is 50 degrees. Doesn't look like it, but it is. Okay, questions on that? That's what you're doing today. Triangles always add up to what? 180. Lots of 180.